Hello. Well, today we're going to texture a cube on the PlayStation Portable. So let's start with a cube. We have the cube from the last video, so if you want to see how to make a cube, go and look at that video or the OpenGL playlist. So I have the code for the cube here. So it does not contain any texture, so we need to add the texture. So let's start with creating a texture. I know I want to use unsigned int here. Doesn't really matter, but that's what I'm going to use. And I'm going to make a texture that's 64 times 64 in size. It's a very small texture. The reason for using unsigned int here is that I want to store 4 bytes, and unsigned int happens to be 4 bytes and easy to work with. That's the only reason for that. Let's create our fill-in texture. We need to walk around all the pixels and set some values in it, because I'm not going to code a loader for loading in graphics. I actually have not a loader, but how to load in graphic in a super simple way in one of the OpenGL videos. So if you want to check out that, go and look at that video. Now let's create a texture. So we're just going to iterate around y-axis and then x, and for each pixel we going to set the color value, and we going to make a small formula here and set 2 different values. There we go. So what I did, I have my texture. I go through it from the top to the bottom. First loop here, oopsie, first loop there on the Y, and then I go on the X direction. Yeah, I know you know how loops works, but anyhow, this is the point of it. Here, I take Y times 64 plus X. So when I'm done with one X line, it jumps down to the next one, right? So when I step Y, it jumps down to the next one. Then we have some magic code here that takes the X value times the Y value, modulus 2 on that. So I get 2 different solutions of that. It can either be true or be false. And then I set 2 different colors. And that would make a checker pattern in the textures. I will have one with a checker pattern. So that's the texture I'm going for. So let's hope that that actually created one of those textures. There we go. Now I need to call this, of course, somewhere. Let's call it from down here. Fill in texture. Now we have our texture. Now we need to enable texturing. So we go up to initialize, go down into where we enable things. So we're going to enable texture. That doesn't look like texture to me. Texture. I'm word blind, but that's probably correct. So I'll enable the texture. Let's run it. And it complains, of course, because I couldn't even create a loop. That's how good programmer I am. There we go. And it works wonderful. Our cube is textured with nothing. I think it's more that it doesn't show anything. We have not set the texture. We have created the texture. We haven't used it. We need to use it somehow. And we need to use it before we draw our object, because we want to be able to change texture per object, obviously. So we're going to load our texture here. And let's see if I can remember this one. It's the format of the texture, and this is what format we have been using before. It's 8 bits, 8 bits, 8 bits, 8 bits. So it's 4 bytes alpha RGB. So that's that, and we need to specify the size of the texture. That's 64 times 64. But we also need to specify the buffer size, which is 64 in this case. And we need to specify the texture pointer where we have stored the data. So we have a memory area that I'm not drawing totally rectangular or square. Which is it? I don't draw it like a square, I draw it like a rectangle. There we go. So this part here and that part here. So all of this, that's our texture. But our allocated RAM for storing textures could be all of this area, and this is unused. And to tell the system that that's how it could be working, we need to specify this length of the buffer. So the system will know when it fills it in later, like, or you read the text, that if you start reading until the width of the texture, then jump down again and continue, but it needs to skip over this part, right? So it reads one line, knows how much to skip over, and then continue reading on the next line. This needs to be 2 power of n, so 64, 128, and so forth. I only think it can be 512 on a PSP. I don't think PSP takes bigger textures than 512 times 512. But anyhow, we've just set all of them to the same, and you see that continuing at other places. So let's see what I have forgotten. I created the texture, I enabled texture, I have set the texture. I have not told our object where to draw the texture, so even if I start this now, nothing will happen. It's just black. I haven't told it where to draw the texture. You need to do that. And then the same as always, like the draw array, we specify here what kind of data we have in our struct that contains the data for the object, and that needs to contain the UV, the XY for the texture. So the texture is, normally we got X and Y for coordinates, but in textures you got UV instead. That just means the same. It's the same. It's just different naming. So we need to add in that. And they go from 0 to 1. And let's we start just adding in zeros here, and I fill in reasonable texture coordinates. And that's really hard to do because I have no clue what coordinates should be on different polygons here. So I will take a guess. I will take a guess. It won't be the best texture mapping ever, but I think we should at least get the idea of how it's working. So I filled in different UV of these, so the X and Z of the textures. So on this first polygon, I know that's the first polygon because in the indexes it says that it's vertex 0, 1, and 2, so that's these 3. I'm going to use 0, 0, 1, 0, and 1, 1 of the texture and mapping to that polygon that's listed on the side there. So now we go down to our draw again, and we need to specify that we are sending in texture coordinates. So it's GU texture and it's 32-bit float. There we go, and then let's run it. And we do not have a texture. So something went wrong. Now let's try to debug and see what I forgot, because I probably forgot something here. We start with disabling textures, just checking that everything is back to normal, and it is. That is fine. Then what have I forgotten? Did I call this method? I did call it. Did I create a texture? I did not. Okay, so let's enable texture again. Still errors. Okay, so I think I figured out what's wrong. I haven't tested it, but it probably is that this value should be the map level. You can have multiple textures. So let's scroll it. So we got some gray area to draw on. So you can have multiple textures in multiple sizes. So you have a big one, you have a smaller one, and you have a really tiny one that displays the same image, just different resolutions. And you're going to use the first one, this one, when you are close to an object, and when it's farther away, when you don't really see the object too good, you use the next one. And if it's really far away, a tree far away or something like that, like you use the third one just to save a bit of memory and moving data around in the GPU. So that's the map level. And the first argument here is the map level and not the texture format. That one is in an own function, and why I forgot this function is because it just needs 3 zeros after. And I actually don't know what the two first one are, and this should really be a due false, because if you turn it to true, it's something called swivel or swivel or something like that, and I haven't read up what that really do, so but I know it works if I put a 0, so it needs 3 zeros, easy to forget. And when now it comes to zeros, this also needs to be 0, because the first map level is level 0. So we're going to use that, and now we have our wonderful small textured cube. I want the texture cube to actually be bigger. The texture itself should be more bigger is the wrong word. You will see what I mean. So I will change everything with the size of the texture from, I should have a define of the texture size here, but from 64 to 16. And there we go. That's what I wanted from my texture. So now we have a texture cube, and go and play. But let's continue the video, because we have a little bit few more topics when it comes to textures. And it's not those that are normal. You have blend and things like that. You have that in OpenGL. I will actually ignore that, because if you gotten this far, you can probably figure out blend, but getting this far might need a video. And the next step, you don't need, but if you want to code on the PlayStation Portable, it's kind of needed anyhow. Let's go through that. That's much more important than just looking up the blend option. And that's our video ROM and how that works. So we got the CPU. And as every other computer out there, we have a GPU. And this is generic, by the way. This is not from the spec of the PlayStation. This is the generic, how that stuff more or less works normally. And it works kind of the same when you think about it on the PlayStation. If you really want to dig down to it, it's not what they have shown here with OpenGL. They have their own special language for sending objects or things down to the PlayStation that's super more advanced than using this version we've been using, but this version is much easier to start there. So we got the CPU, we got the GPU, and we got the RAM. And if you have come from other computers like C64s or older computer, 8-bit computers, you will know this stuff, I guess, if you looked into them. But maybe if you just come from PC, maybe you haven't thought about it, but the CPU has a view of a memory, so it can access the memory. But the GPU might not have the same view. It might not even have the same memory, to be honest. GPU could have a memory on the side that it talks to that the CPU can't touch. That's kind of half true what we have in PC. And then we have this like this also, that the GPU might have possibility to access some of the RAM or even all of it that the CPU can. So notice the things to take away here is that the RAM that can be accessed by the CPU and GPU does not need to be the same size, does not need to start at the same point. So this point could be 0 for the GPU, and this point could be 0 for the GPU. And also the CPU and GPU might access this memory at the same time. So the GPU might access that while the CPU is busy accessing this one. And if you would really want the GPU to be detached, then it could have some separate RAM. So why do I go into all of that crap? It's because of our video ROM. We have set it to 0. If you set a pointer to 0 and use a 0 pointer in C, you get in trouble. You get segmentation fault and your program will crash. So why doesn't our program crash? I clearly set this to 0. I clearly do math on it, and I clearly send this down to the PlayStation to fiddle with and use at the GPU level. So why didn't it crash? And that's because this is not the correct address. It's not 0. That's not the true RAM. So we have the RAM, of course, starting from some 0 and going up to some value, and the CPU again accessing 0, segmentation fault. But the GPU that we're sending down these values to, the GPU doesn't see the same 0, it sees another 0. And for the GPU, it doesn't care where it accesses memory, it doesn't malloc any memory, it just has all the memory, it has access to everything. So 0 it is, and we're going to go on 0. So we're setting the video RAM first. That's our display. After that, we're setting the draw RAM. Then we're going to draw in. That we're later going to flip over to the display. After that, we had the depth buffer. After that, we had the set buffer. And we're going to introduce the next buffer after that. We're going to introduce the texture buffer, where we're going to store textures. Because it's much faster for the GPU to access texture memory than try to compete with the CPU and go in to find a texture in the memory that both the GPU and the CPU can access. So we need to create a new one. We need the texture RAM. So this is only for speed, to make it, if you can access the texture from the other method like we have, I mean, we have it working, it works fine, you can make a game like that, but it goes faster if you transfer the texture into the video RAM or the part of the RAM that the GPU can access. So we're going to copy the size of this one. And I changed that to 2 because this is actually the size of the set buffer we're adding on. And that has a short only per pixel, so that's why it is 2. And the texture RAM I need to be able to access from a method below this. I will move it out from this function. There we go. Now we have some space to take. Now we have a place to put the texture. Now we need to transfer the texture over from in CPU memory to GPU memory. So we need to do a sceGuImageCopy image. And we're going to specify what format our image is in. We're going to specify the coordinate we want to start copying. Going to specify coordinate we want to end copy it. So again, so this is not hard at all. We are just going to specify 0, 0, and 16, 16. That's all. And we need to specify the width of the buffer. That's also 16. Then we need to specify our texture. And then we have pressing the wrong key when getting this drawing tool up. Then we have the video ROM, and we need to specify where in the video ROM we're going to place this object. So we could place it up directly here. Seems fine. And that's 0, 0. So that's where we're going to place it in the video ROM. So this 0, 0 reference an offset to that address, and this 0, 0 will reference an offset to the next address. But first we need to specify the width of the buffer here, which is just set to the same as the texture. So our texture will take the full video ROM. And then we need to specify the texture RAM. But no, this is wrong. So we have the texture on. We have specified we want to copy the texture from the texture pointer we have defined it. This is the size of it. This is the buffer width. We want to copy it there. This is the buffer width, and this is where we should copy it. That should work, right? It does not. And it does not cause of the addresses are seen different between the CPU and GPU. So I'm repeating this a lot of CPU and GPU now, but it is important. So you got the CPU, and it looks at its memory. There we go, memory. And we got the GPU, and it looks at its memory, and it starts at 0 there. And we have the CPU saying, no, 0's over here. So they disagree about where the 0 are. So we have specified 0 and then some math, and we got the texture ROM, and we have texture ROM, but that is somewhere over here, according to the CPU. Way off. We need to move it over here. So we need to ask. Let's see, delete that. I should really learn that key combination. We need to ask our framework where the video memory starts. Let's see if I can remember this now from my head. It's sceGIME get addr. That's our address of our video memory. It happens to be static, and I happen to know what it is, but this method is the way to get it. If someone wonders, it's a 4 and a lot of zeros. I should probably know how many. There's also a method called size that will return the size of the video RAM. So it could be good. I think it's difference between the different version of the PlayStation. I think the later one has a little bit more RAM, if I'm not incorrect on that. So we're going to copy over the texture. We're going to specify the texture RAM, and we're going to plus with texture RAM happen to be a void, so we get an error or compile it. So I just cast it along there. So we're going to add that to our start of the video RAM and copy over our texture. So we need to wait until this command has finished, because this command actually tells the GE extra chip in the PlayStation to do this for us, or it's some other GMA function, but I think it's the GE chip that does it, even though it's a GU function. But we need to wait for the texture to flush, meaning it needs to transfer over. We're just going to block and wait until it's transferred over. So now we have our texture transferred over. Then we of course need to change where we telling our system to use this texture, because it's still using the old texture. Down here, sceGU text image, we need to update that to that other address, and then just run it. And it looks exactly the same, and you say like, nothing happened, but yeah, something did happen, because if I mess with this address here now, what should we do? Take minus 32 in the middle of it. Just because, why not? And we cut a hole in the texture there. That was just too little, hard to see. I think that would cut out the full texture. Anyhow, so if you mess with that address, the texture is actually in the video RAM now. I could get the old texture if I do like that, but that doesn't work anymore for some reason. Not trying to figure that out right now. So that's how you transfer a texture into the video RAM, which makes it faster, else you will not be able to draw full scenes on the PSP. So that's texture mapping. Good luck coding. Hello, editing me here. So after I created the video and actually uploaded the video, I was smart enough before making it public to actually test it on the PlayStation, and yeah, that doesn't look like it should. Also the problem focusing here. Can I get to focus? There we go, focus, perfect. So you see that the texture is totally trashed, and that's not how it looks like on the emulator. So another good lesson of actually testing things on the real device when developing. It takes a bit longer time to do that, so that's mainly why I'm running it on the emulator. Yeah, so I guess I need to make it look like that somehow. Okay, I got it working. So now I have an image of my cat here instead, cat face. I mean, the texture isn't aligned correctly on the cube, but that's fine. I mean, it displays the texture, that's the point of it, and it has no errors. I'm a bit confused why the other texture had errors and this does not, because the only thing that's really different and what I changed, took me 2 hours to change the size of the texture. So I had this super small size of texture, 16x16, and now I just loaded in the 256x256 texture instead, and that seems to be working. I have no clue actually what went wrong, but I got the textures to working, and that's the main point of this video. So I will actually check in the code I got now. What's the difference are that I set a white on all polygons instead of colored vertexes to make the image pop a bit more. Then I included the image. I defined here that I use so the compiler shouldn't try to compile this crap. If it compiles it, I get 2 symbols, one in the main file here and one in this image file, and then the compiler complains, and I add this one to skip this path and only compile it when it's included here. And then I modified my copy texture to video RAM that takes the image data, pixel data, and 256, 256, 256, 256, which is the new texture. Can we get back a picture there? And then I scroll down here, and I'm just setting that I'm using 256, 256, 256 instead of 16, 16, 16. And that was everything I needed to do to make it work. Like I said, I got no real clue what's going on. The texture I used before was an unsigned int, and from what I know, that's 4 bytes. And this one is pixel data, that's 256, 256 times 4, so that should be the same. Only difference I can see, it has an extra byte in the end, but that can't have anything to do with it. So yeah, I am confused, but yeah, the source files will be linked in the description, and good luck coding.